Students, welcome to ZimSIC Robotics Lab. With me, the Zim Science General. This is a series of videos where we cover combined science syllabus topics from Form 1 to Form 4. So watch this video to understand the following topic better. Discussing resistors today. Resistors are electrical components whose main purpose in electric circuits is to control or reduce the amount of current flowing in a circuit. We have two main types of resistors: the fixed resistors and those called variable resistors. Fixed resistors, the value of resistance does not change irregardless of changes in current. Then the symbol for a fixed resistor is a box and two lines coming away from the box. Then we have variable resistors. Their resistance or the values for resistance changes or can be adjusted. Then symbols for variable resistors. There are many different types of variable resistors, each with a special symbol. But the most common variable resistor in our laboratories is a rheostat, whose symbol is like this, a box and an arrow. SI unit of resistance. The SI unit of resistance is an ohm, which has got this symbol. Then how do we connect resistors in electric circuits? There are two ways of connecting resistors in circuits. We have the parallel way of connecting resistors in circuits, or the series connection. We start by looking at how resistors are connected in series. Starting, for example, with two resistors in series. Two resistors in series. Yes, we have two resistors in series. Then we number them R1 and R2. Then how do we calculate, how do we find total resistance of resistors in series? It's very simple. What do? We say R total is equal to R1 plus R2 to get total resistance. Let us look at one worked example. Calculate total resistance in the circuit diagram given below. This is the circuit diagram. Don't forget that this is a cell. Don't also forget that this is a resistor, R1. Then this one is another resistor in series which we have labeled as R2. And look at the closed switch. Switches are connected to the positive terminal. Then R total is, we write the formula first, then we substitute the formula. R1 is 3 and R2 is 6. It is advisable that you don't write units in the working. Then your final answer should have the units. 3 plus 6, it's 9 ohms. We want now to show how resistors can be connected in parallel. So we take two resistors, we connect them in parallel to the circuit, R1, R2. Then how do we find total resistance if these are in series, in parallel connection? we say 1 over R total, which is equal to 1 over R1 plus 1 over R2, and so on. Then how can we simplify this equation to make it simple so that we can easily use it? Then let us make R subject of the formula. R1 over R total is equal to R1 plus 1 over R2. So this is 1 over R1 plus 1 over R2. Then we look for the common denominator for R1 and R2, which is R1, R2. Then we cross multiply by R1, R2 times R1, then R total times this is given here. So then we want to make we want to have R stay on his own side. So we divide this whole lot with this one, and we also do the same here. Therefore, R total becomes R1 plus R2 times R2 over R1 plus R2. So this is the formula that you need to master when you are calculating resistors in parallel. Please master. The top is multiplying, the bottom is adding. Then let us look at one weak example. Calculate total resistance in the circuit diagram given below. Look at our circuit diagram. We give names again. R1 to this one, R2 to this one. Then the solution, we now use the simpler version of the formula for finding total resistance when they are in parallel connection. So the top is multiplying 3 times 2, 3 times 6, and the bottom is adding 3 plus 6. We get 18 over 9. Then R total is 2 ohms. Did you notice from our workings below that resistors which are connected in series give total resistance that is higher than if the resistors are connected in parallel? So arranging resistors in series will give a resistance that is bigger than if you arrange resistors in parallel. Then connecting resistors in both series and parallel. 3 resistors connected as follows. Look at one. R1 is in series with R2, and R1 is also in series with R3 as given by these notes. R1 and R2, they are in series. Then R1 and R3, they are in series. Then only resistors R2 and R3 are in parallel connection. Then let us now work out the problem involving resistors in both series and parallel connection. The example is find total resistance if the circuit diagram, in the circuit diagram below, we have resistor 1 in parallel to R2. Resistor 1 is in parallel also to is in series connection to R3. Then only R2 and R3 are in parallel connection. Then when we want to find R total, we take R1, which is in series, plus, then we open brackets and work out the two that are in parallel connection, one over R2 and 1 over R3. Then R1, which is in series to the rest, to each of the two, R2 and R3. Then we we substitute with the easier formula to use. Then 4, which is R1, plus, we open brackets, R2 is 2 times R3, which is 3, over the bottom, which is adding 2 plus 3. Then once we get 4 plus 2 times 3 is 6, 2 plus 3 is 5. Then the total is 4 plus 1 over 2. Then the total resistance is 5.2 ohms. We should ignore using units while we are working out the answer. Only the answer should have the correct symbol or a unit. Then we now want to use Ohm's law, which we discussed in the previous video, to calculate the value of V in the circuit above. V, which is the unknown. So V, Ohm's law is current times resistance, total resistance. We use total resistance. You should know that. Then our current is 0.5. Then total resistance that we have just calculated above is 1.5. Then if you multiply this, the voltage is 2.6. Thank you. See you in the next video. Thank you for watching this video. Please like, follow, and subscribe to our Facebook page and YouTube channel.